Now here, we're talking about secure communications, and that's the third use case from the left here with the red circles. And that is the most near-term application for an entanglement-based network. And that's partly because it's the simplest to construct, and partly because there's a high, as we discussed on the very first slide, there's a very high demand, a very high sense of urgency to move to a more secure method of communications. But it's important to note that an entanglement-based network can have other use cases. You can almost think of it like, TCP/IP in quantum, where you can build different applications on top of it, and some of the ones that are going to be built, we can't even guess about yet. I mean, when TCP/IP was being developed, no one really envisioned things like Uber or Airbnb or Discord or things like that. So here we show a few use cases that we know are coming. On the left side is the networking of quantum computers. Every quantum computer manufacturer will tell you, and every cloud giant that's selling quantum computing as a service will tell you, they need to network the quantum processors together. They need to network them together to get more qubits to be able to solve bigger problems and make the quantum computers useful. And so there are data center networks being built that use entanglement to connect quantum processors. On the far right of this slide, we're showing the networking of quantum sensors. There are many quantum sensors on the market. Atomic clocks are an example. There are also quantum sensors, gravitometers and magnetometers that sense metal. And these sensors capture a quantum state. And if you can network those quantum sensors with entanglement, it's been proven you can get a much higher resolution. For example, a much higher timing resolution, which would give you a much better precision in positioning assets and things. So networking quantum sensors is another application of entanglement-based quantum networking.